In this video, let's try to understand the next important part in any coordinate geometry system, section formula. Now, in the previous video, we have discussed and did some of the problems on distance formula, correct? Now, section formula is what you have 2 points and another point is going to divide it into particular ratio, correct? Now, you guys know the section formula for 2D. It's very similar. Okay, now for that, see what you have the xyz axis. This is the origin O. Now 2 points will take here. Say this is A, say this is B. A and B are 2 points. Now these 2 points are divided by some other point, let's say P. Okay, and this is divided in the ratio m:n. Now what we do here, see generally what we do, we take it as x-axis, y-axis, z-axis, correct? Now, perpendicular to the z-axis on the xy plane. Okay, I'll repeat this again. Perpendicular to z-axis on the xy plane. In the sense, suppose if this is the xy plane, then perpendicular to the xy plane. So this is going to be the perpendicular, sorry, this is going to be parallel to the z-axis. So parallel to z-axis, perpendicular to the xy plane. We are going to draw two lines perpendicular. So it's going to be something like this and something like this, perpendicular. So from P also you drop a perpendicular. Okay. Now what we can write is we can write this in terms of the ratio m:n. Okay, we can write in terms of the ratio. But here, since it is perpendicular to x and y and parallel to z, what we can write is that ratio m divided by n. Sorry, m divided by n. This ratio is equal to, now what we'll do, see here, this point, and this point. These 3 points we can easily calculate, correct? Now, how we can calculate? Now, to get to point K, say this is K, L and M, okay, some point. Now, to get to point K, we just have to do x1 in the x-axis, y1 in the z-axis. Sorry, y1 in the y-axis, which is in the xy plane. Very easy to calculate. Same way we can do for L also, same way we can do for M also, correct? So for all the 3 points K, L and M, we can calculate the coordinates, isn't it? Now what you have, that M by N ratio. So we can write this as AP divided by PB. Now what we'll do, join this K, L and M. Okay, now join this one. Now in 3 dimension, remember this is, everything is in 3D. Now we are going to draw a line parallel to KM. So something like this. Something like this. Okay. So, or rather you can also write it something like this. So here this part is not there. So it's going to be only this much. So like this we are going to draw. So the parallel line, let's call this as R and S. Okay, R and S. So here SR is parallel to KM. It might not look like parallel here, but remember we are looking at this in 3 dimension. Okay. Now in this case, M:n is AP is to PB. Correct. Since we have AP is to PB, now the same thing what we can write. Now here this KL is equal to SP and LM is equal to PR. Correct. Now what you have is that this one SP is equal to KL and PR is equal to LM. Now this we can easily calculate, isn't it? Now once you have this one, SP is equal to this. Now what we can do, if you're talking about M is to N, we can also take the triangle ASP and BPR because these two are in the same plane. Since we can take these two triangles, we can prove that they are similar to each other. Alright, by AA similarity, we can prove that they are similar to each other. Since they are similar to each other, what we can use is that we can use the side ratio. So here what we can write, AP by PB is equal to SA divided by BR. Now SA by BR, this can be written as SK minus AK divided by, so this you can write it as BM minus RM. Okay, BM minus RM. Now what you can write, the same thing we can also write in terms of Z. Okay, now see, AK is nothing but Z1, correct? Now SK is nothing but PL here. So what we can write this as PL minus AK divided by. So this is one part, and the next part is going to become BM minus RM is nothing but PL. So what do we get? M is to N, or M by N is equal to Z minus Z1 divided by Z2 minus Z. Cross multiply. If you cross multiply, you'll get MZ, this one, sorry, minus MZ, and then plus M into Z2 is equal to NZ minus N into Z1. Transpose. If you do that, you're going to get MZ plus NZ is equal to MZ2 plus N into Z1. Correct? Now what do you have? If you take Z common, Z is equal to MZ2 plus NZ1 divided by M plus N. Now similarly, here we took a perpendicular to the XY plane, correct? Similarly, if you take perpendicular to the XZ plane and if you're going to take it as to YZ plane, similarly you're going to get for X and Y also. In the sense here, if you take it for the X, Y and Z, then the coordinates of point P, it's going to become mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n, and then mz2 plus nz1 divided by m plus n. So this is going to be the coordinates of point P, x, y and z. This is the final formula. Now, with the help of this, suppose if the point of intersection is external, this is internal, point P was in between. Now, what if it's external? External in the sense something like this. You have 2 points A and B. Now, we have another point P somewhere over here. This is point P. Now, this entire thing is M. This entire thing is N. Now, this is external division. Fair enough? Now, for external point, the coordinates of P, it's the same thing, but mx2 minus nx1 divided by m minus n, then my2 minus ny1 by m minus n, mz2 minus nz1 divided by m minus n. So this is going to be the point, the external point of division between point A and point B. Now the previous formula is the internal division. This is the external division. Okay. Now what if the point is a midpoint? Then it's very easy. You know that the ratio is going to be 1:1. Correct? So the midpoint formula is M is equal to x1 plus x2 or x2 plus x1. You can write anything. x1 plus x2 by 2, y1 plus y2 by 2, then z1 plus z2 divided by 2. See, this is the midpoint formula, right? Now, the next one is, what if the ratio is not given? Then you take it as lambda is to 1. Okay. So, if you're taking it as lambda is to 1, you guys have solved problems like this in 2 dimension, isn't it? It's the same thing. Suppose if the ratio is not given and they'll ask you the ratio, then what you do is that ratio you take it as some value lambda, or you can call it as k. Okay. Then your point, or the ratio and the point P is going to become, again, it depends on what you're taking. M by n, if you call it as lambda, then this is going to become lambda x2 plus x1 by lambda plus 1, lambda y2 plus y1 divided by lambda plus 1, lambda z2 plus z1 by lambda plus 1. Remember, this formula we use when the point is given, but the ratio is not given. Clear? This is the midpoint formula. And above, we have discussed about external division and internal division. So this entire concept of section formula, whatever we have discussed. Now, the problems based on this, we are going to discuss in the next video. But here, few points are very important. Okay, do not confuse x1, y1, z1 or x2, y2, z2. Whatever it is, do not confuse that with the centroid formula what you have learned in the previous chapter. Okay, so that is different. This is different. Do not get confused. This is the first point. Okay. Now, the second point what I want you guys to understand is that whenever you do 3-dimension geometry, try to visualize the particular problem. Okay, try to visualize that, okay, this is where the problem, this is where the point is. This is how the problem is going to be. Okay, try to visualize. Fine. So in the next video, we'll discuss problems based on the section formula. Fine. In the next video, we'll discuss problems based on whatever concept we have learned so far.